Welcome, chemistry. You should be tuning into this video looking for information on 11.6. If you are not looking for information on 11.6, you are watching the wrong video. So what should have happened by now, you should have read 11.6, taken the 11.6 quiz, graded the 11.6 quiz, know sort of what's a little bit about what's going on. And then there could be two papers in hand that may help you that I'm working from right now, which is the 11.6 quiz itself. And then one year I made up this paper that's titled Math Examples 11.6 because I must have been missing school for a summer. Probably the sports meeting that happens around this time every year, or who knows. But this was designed to be a paper to be taught without me. So we use this sort of with me and sort of without me because you're watching me on video, but I'm not actually with you because that'd be a little creepy. So 11.6 math examples is what I'm going to be sort of doing for you live and in person. But first we'll start with the 11.6 quiz information. The 11.6 quiz, the only new thing for number one was a thing called the combined gas law. So the combined gas law is what it sounds like. They took all the gas laws and they combined them. So next quiz up, you're going to need to know this equation, and that would be the only new bit of point, I think, in terms of changes. So when you go to read 11.7, there's two new points, fill in the blanks from reading 11.7. Then there's a third point that's like a short answer-y kind of question from 11.7, so three new ones. And then compared to today's quiz, number 2 and down, all that stuff stays the exact same. And then number 1 today moves to the bottom to be number 2 or 26 tomorrow. So right after you're answering about adding 273, it'll ask you give an equation for the combined gas law at the bottom of tomorrow's, and it's this. So combined gas law information and or a recap of just the old laws. We had Boyle's law. Boyle's law was first. Boyle's law starts off by talking about at constant temperature. So if they're going to do constant temperature, basically that doesn't exist. Temperature ceases to matter, and that's Boyle's law. The second law we did was Charles's law. Charles's law says at first constant pressure. If we say constant pressure, it's like pressure doesn't exist, and we're doing that equation for Charles' law. And then Gay-Lussac, who I think is the least impressive of the three, because he just kind of ripped off those other two guys' ideas and made like a new variation of the same thing. But Gay-Lussac comes in, sorry if you're a big Gay-Lussac fan, I didn't mean to step on your toes. But Gay-Lussac's law starts off constant volume, which means basically that doesn't matter, and then we had that equation already for Gay-Lussac's law. I'll let you in on a little secret. If you knew none of those other laws, and you just learned how to manage this law, you're good, because this covers every possible combination, and if they just happen not to mention one of the items, skip it. Or if they happen to say at constant whatever they picked, skip those. And this law can cover like the whole chapter. So if you've understood nothing, but you understand how to work this when we're done today, we just fixed all your problems from the whole chapter. If you would approach me on a random day 6 years from now and say, what's the combined gas law? I will know this. If you walked up to me and said, what's Boyle's law? I might or might not know that. Charles, Gay-Lussac, I don't always keep those all straight. While we're in this chapter, I know them, I'm good, we're using them, they're fresh, I'm on it. But like, on a normal day that I'm teaching physics, I might not know which law is which, to be quite honest with you, because I have this firmly in my mind, and I just think in terms of this every time. Even when we're doing those other laws, I've been thinking this whole chapter. But that's our information so far. So mathy stuff, there's an example, 11.6. So the example 11.6, just like being in class, I don't know where anything is. Books here, chalk's there, it's exciting. So 11.6 this, I'm on page 289. If you're not on page 289, go ahead, pause, get to 289. I'll be back with you in a minute after you pause me. On 289, it says a certain gas occupies 500 milliliters at 760 millimeters of mercury and 0 degrees Celsius. That's all in one sentence, so that's all going in one fraction. Every sentence makes a fraction. So just don't try to mix and match sentences in different parts of the fractions. One sentence, one fraction. So we read, it says milliliters, the units are your biggest key to match who's where. Milliliters are always volume. So we've got a volume number 1, 500 milliliters, but once we've done the milliliters, we are committed to milliliters. If this one's milliliters, this one has to be milliliters. You hope they don't mess with you on that, but every once in a while you know full well they're going to do that. And you might have to switch a unit with a little side dimensional analysis, milliliters make liters or something like that. But we have 500 milliliters, 760 millimeters mercury, so 760 millimeters mercury is the key. That's one of our pressures. We've had 8 things on the quiz day after day after day about the pressures, the ATMs and the pascals and the torr and all of that. But millimeters mercury certainly in that family, so that is pressure number 1. If they didn't want to give you that number, they could have said standard pressure. If they said standard pressure, that is one of our standard pressures, we might have grabbed that. But now that we've committed to millimeters mercury of this one, we are committed to use millimeters of mercury for the rest of this problem. And you hope they match, but if they mismatch you, you're going to have to just deal. 0 degrees Celsius might tempt you for a second to put a 0 on the bottom, but math experience should teach you to never put 0 on the bottom. And other lessons experience should be still the same. The temperatures have to be Kelvin. So we're going to do the 0 plus 273 is that. After the equals, we need to seek then the other sentence. If you're confused how those happen, rewind, watch it again. But we're looking to go for the next sentence, milliliters, which we're good. This was milliliters, so we're good over here for milliliters, but we don't know what it is. We're going 10 ATMs, so 10 ATMs is going to be a problem because the 10 ATMs is not going to be friendly with 760. So we're going to have to change one of these. And it doesn't matter which one we're going to change, but just for consistency's sake, I'm going to look at the paper and change the one that's on the paper. But the 760 could be changed, or the 10 could be changed. I'm going to guess I changed the 760, so let me see. Looking at the paper, yes, I changed on the paper because they were mismatched. The 760 millimeters mercury, I just traded, because it's on the quiz, traded for any of the other ones we need on the quiz. 760 is a fair trade for 1 ATM. So over here, we can use the 10 ATMs. Reading on in the sentence, we have 100 degrees Celsius, so we add 100 to the 273. We always have to add 273 to get the Kelvin, to get the Kelvin temperature on the bottom, and now we're set. If you don't understand how we're set, then watch it again. I'll do another one too in a second. So now it's algebra time, a little bit of sort of cross multiplying. The quickest way to do this is hope the variable's on the top. It is. Take anything on the top and send it down to the bottom. Anything that's on the bottom, send it up to the top. And all these top numbers I'm going to multiply. All the bottom numbers I'm going to divide. So I'm going to punch this in as, I'm not going to personally punch 1 times that, because 1 times stuff, that's dumb. But if you want to go 1 times stuff, it's not going to hurt anything. But I would go this number, normally if it weren't a 1, times the 500, times the 373, divide by key for 273, divide by key again, because the 10 is going to be on the bottom, hit enter, and your screen should read you something that's going to start with 68, have a decimal, and a position here that's going to round to be a 3, third position will round, and then the unit on that is milliliters. Go again, same kind of thing, 11.7. So I'm up 1 page, I'm now on page 290. So on this, it has 20 liters early, 20 liters early, that is a volume. It has, I'm just gonna skim ahead. You don't have to you can get these slotted any order you want. I see it 75 liters later, so I'm gonna go 75 there. So I have my volume spots filled because volumes are liters. So I'm just filling those slots with liters. 20 now, 75 later. Temperature, I see 50 now, so 50 adds 273. I see 0 later, so we add 273. If they want to be a little meaner, they could have said standard temperature and make you know 273, but they didn't do that there. We're looking at 780 tour at the beginning, and a mystery number a tour later, so they were kind. We didn't have to switch anything this time. We can just use the 780 as it is. We can just throw a variable on there as it is. We can look then to do our little cross multiply. Again, any bottom numbers come into the top, and we're going to do multiply buttons for all of those numbers that are on the top together. Then any top number can go to the bottom, and we can hit the divide button for anything that's on the bottom. So this is going to punch this times 780 times 20 times 273, all times for the top. Divide by 323 for the bottom. Divide by 75 also again. I hit the divide key twice because there's 2 things on the bottom. Hit enter, punch, punch, punch. Screen reads 17 and whatever it is that rounds to 6. And then this unit has to match what the 780 was, which is 4. And then we're good for that. It's right now a little early in the AM, 11:05 AM on what is today, Tuesday, March 17th. So some of you might still be sleeping for all I know. I have no questions have arrived yet on any of the homework from, it would now be 19 and back is what should be done. If you have questions about anything from 19 and back, email me, I'll throw it in a video. But nothing made it in time to be part of this video, but maybe next time. What you're working on in the new thing is 20 to 28. 20 to 28 will be more like these. One what if that probably occurs is there may be some where the X is on the bottom. If you get one where the X is on the bottom, feel free to just flip both fractions. So if you have like 2 times 3 on top of 4 equals 5 times 6 on top of X. Realize those are smaller numbers than you're going to see, but just to keep it quick, I would take that and just transform it into being 4 on top of 2 and 3, X on top of 5 and 6, and then do the same thing. Okay, we would just have to take these bottom numbers to the top and go 4 times 5 times 6, divide by 2, divide by 3. If that made sense, use that. If you want a little trickier zigzagginess, alternative plan would be to zig this up off the bottom. Then you'd have to zag those down to the bottom. The X would then be living here. The numbers under my hand living there. And then to get the X alone, the 4 would have to maneuver up. We'd have 4 times 5 times 6, divide by what's under my hand. Divide by 2, divide by 3. If you like that better, that works too. What you hope for is the X isn't on the bottom. If the X is on the top, your life is simpler, but every once in a while the X is on the bottom. Odds are against that though, because just looking at sheer odds of this thing, there's a whole lot of things on the top. There's only 2 things on the bottom, there's 4 on the top. It's twice as likely your unknown thing is going to be on the top, but you're probably going to have to deal with it at some point with the variable on the bottom. So either flip them both and do the same process, or go crazy fancy zigzags. So I'm sure you're all waiting for the deleted scene, special bonus features, so that'll be up in a minute. I sent you a little bit of word when I saw people picking up packets yesterday, gave you a little teaser information, there'd be a bonus feature, because I wanted to get some buzz out there, pun intended. So we'll see how this goes. I think you'll enjoy the bonus feature though. You ready?
I am ready.
So why don't you get on me? So today, part of the video, we will include a special bonus feature.
because spring has sprung, and I know some of you enjoy when this happens. So we have our first sighting of the year, and it is time. Some of you know already what this means. Emily can get a zoom in on our small friend.
Okay.
Bye-bye, bee. Bye-bye, chemistry.